In this lecture, let's discuss about inverse of the non-singular matrix by Gauss Jordon method. This method is used to find the inverse of the given matrix, and the formula which we use to find the inverse is A equals to I into A inverse. Here I is the identity matrix, and in this method only row reductions or row operations are allowed. Column operations are not allowed. So let's take an example matrix and let's try to understand the Gauss Jordan method by solving that matrix and finding its inverse. Here this is the example matrix where A equals to 133, 143 and 134. This is a 3 by 3 square matrix. So the formula will be A equals to I3 into A inverse. So this is the formula for this matrix. Now let's substitute A as this matrix and I3 as a 3 by 3 identity matrix, and the inverse will be same. So after substituting, this will be our values. A equals to identity matrix into A inverse. Now we need to reduce this matrix into identity matrix by performing row operations, and we should also perform those row operations on this identity matrix. After reducing this matrix into identity matrix, there will be some resultant matrix over here. This resultant matrix is considered as A inverse. Okay. Now in an identity matrix, these three elements should be 0. So here we have 1, 4, 3. So R2 implies R2 minus R1. Then 1 minus 1 will be 0. Okay. Yeah. Now let's perform R2 minus R1. This R2 will become 1 minus 1. That is 0. 4 minus 3, 1, 3 minus 3, that is 0. Even on this matrix also we need to perform this operation. 0 minus 1, this becomes minus 1, and 1 minus 0, that is 1, 0 minus 0, 0. Now look at R3. Here in these two places we need to get zeros. So R3 implies R3 minus R1. So 1 minus 1, 0, 3 minus 3, 0, 4 minus 3, 1. Here also we need to perform the same operation. 0 minus 1, minus 1, 0 minus 0, 0, 1 minus 0, 1. So I'll be writing these two matrices over here. So after performing these operations on these two matrices, we got these two matrices. So here we can see that we are having two threes over here. These values should be 0. So we can multiply this row with 3, then this becomes 3. So then we need to subtract R1 minus R3. Then we get 3 minus 3 is 0. Sorry, R2. R1 minus R2, then we get this as 0. So now we need to multiply this row with 3. 0 into 3, this becomes 0, and 3 ones are 3, 0 into 3, 0. So 1 minus 0, this is 1, 3 minus 3, this is 0, 3 minus 0, 3. Even we need to perform on this matrix also. So first we need to multiply this row with 3. Minus 1 into 3, minus 3. 1 into 3, plus 3. 0 into 3, 0. Now 1 minus of minus 3. This is plus 4. 0 minus 3, minus 3. 0 minus 0. We get 0. Now after performing this operation on these two matrices, we obtained these two matrices. We can see that we are having 3 and we need to make this element 0. So here we are having 1. We need to multiply this 1 with 3, and then we can subtract 3 minus 3, R1 minus R3. Then first multiplying this row with 3. Now 0 into 3, that is 0. 0 into 3, 0. 1 into 3, 3. Now 1 minus 0, we get 1. 0 minus 0, we get 0. 3 minus 3, we get 0. And in the same way perform this operation on this matrix. We get 3 into minus 1, we get minus 3. 3 into 0, 0. 3 into 1, 3. 4 minus of minus 3, that is 7. Minus 3 minus 0, minus 3. 0 minus 3, that is minus 3. This is the identity matrix. This can be written as I3. This A inverse can be sent to there. So here I3 into A inverse equals to this matrix, and I3 into A inverse can be written as A inverse. Therefore, A inverse equals to this matrix. We use this method to find the inverse of the given matrix. We found the inverse of the given matrix. First, we need to take the given matrix and then convert this given matrix or reduce this given matrix into identity matrix by performing several row operations in order to obtain inverse of the given matrix. So this is the Gauss Jordan method. Thank you for watching this video. Let me know on which topic I should make more videos so that it will be useful for you. If you haven't subscribed for this channel yet, please do subscribe. Thank you.